Right angle. So this is a name given to the angle 90 degrees. So whenever the angle between two rays is 90 degree, we call it a right angle. Now there is another way of defining a right angle. It is that angle which corresponds to 1/4 of a revolution. That means you rotate something, you rotate a ray only by 1/4 of a revolution. 1/4 is nothing but 1/4. So not one complete rotation, just one part out of the 4 parts of one revolution. So one revolution is, let's say you started rotation from here and you completed one revolution here, right? So 1/4 of this. So 1/4 of this would be only this part. So you see, only 1/4 of a revolution. That is a right angle. So it corresponds to 90 degrees. So this is the name that is given to this particular value of the angle. Similarly, you have something as straight angle. Straight because this angle is formed on a straight line. Now what is a straight line? This is a straight line. So this angle is 180 degrees. So the angle, the name given to the angle corresponding to 180 degrees is straight angle because it forms a straight line. Now the question is, how much of a revolution is 180 degrees? It is 1/2 of a revolution. So 1/2 of a revolution corresponds to a straight angle, that is 180 degrees. And finally we have complete angle. Complete. That means one complete revolution. So one complete revolution would correspond to how many degrees? Yes, it would correspond to 360 degrees. That means you start from here and you come back to the same position. So that is 360 degrees, and this is called a complete angle. So it is very easy to remember. Complete means you completed one revolution. So it is complete angle 360 degree. Straight angle means it forms a straight line. So 180 degrees. Right angle. So here in this case, because you just covered 1/4 or 1/4 of the revolution. So these are the three names which are given to three specific angles: 90 degree, 180 degree and 360 degree. Now let's take the example of the clock to see the application of each of these angles. Have you ever observed how time changes in the clock? It's 3 o'clock right now. So what is the angle between the minute and the hour hands of the clock? So if you see, the angle is a right angle, that is 90 degrees between these two. Now, let's say that as time passes by, you often reach a time like this. What is the time now? It's 6 o'clock. And what has happened now? Now, this hand of the clock has actually rotated further. So earlier it completed only 1/4 of the revolution. Now it completed half of the revolution. So it has formed a straight angle. Now again, as time passes by, what happens? From 6 o'clock, it becomes 9 o'clock. Right? So from 6 to 9, again what happens? In this case, this hand of the clock has actually covered 3/4 of the revolution, if you look at it, right? So it is gradually, this angle is increasing. So how much is this angle? This is not 360 degree because it hasn't completed 360 degree yet. So what do we call this angle? That we haven't learned yet. That what can we call an angle which is exactly between 180 degree, that is straight angle, and a complete angle. Okay, we will learn that in the next slide. And finally, the clock strikes 12. So actually this minute hand has, so this hour hand had actually covered one complete revolution. So now it has completed 360 degrees. So here this is your right angle, this is your straight angle, and this one is your complete angle. So when you observe the angle formed between the minute hand and the hour hand of the clock, so what do you see? You see that as time passes by, from 3 o'clock to 6 o'clock to 9 o'clock to 12 o'clock, the angle also keeps increasing. Now here I would like to bring to your notice a very simple thing which might create confusion in your mind. Now you might say that, okay, in this case, we saw that the angle between the two hands of the clock was 90 degree. But when you consider this case, here also the angle between the two hands is 90 degree. But why are we considering this angle and we are saying that the angle is more than 180 degree? That's because you always need to remember from where you started counting. So I will give you one example. Let's say that you participated in a race. You are running and you have to cover, let's say, some kilometers by running, and you started from point A. So this is your start point. So you started from here and you have to reach a point B, so that this point is your destination. Now let's say you are running, you reached a point here. Again you ran, you reached a point here. So as time is passing, what is happening? The distance that you are covering is increasing, right? Now let's say that you have reached a point here. So now if I ask you that how much distance have you covered? So what is the distance that you would calculate? So the distance that you have already covered from wherever you have started, that is from point A, you will measure the distance that you have covered. Now instead of that, if somebody starts measuring your position right now from your destination point, will that give the right result? No, because your destination point is where you want to reach. But for whatever distance you have already covered, you have to measure the distance from your starting point. So the same concept is true here. So this was your starting point, right? So from the starting point, so you started measuring this angle from this 12 o'clock with respect to the hand of the clock corresponding to this 12 o'clock. So this was 0 degree for you and this was 90 degree for you. Now when this hand of the clock has moved further, so your angle has increased. Now this time also when it has moved further, you are still going to measure it with respect to this hand of the clock. So this time you are not supposed to measure it in the opposite direction. So you are going to measure it with the same reference. So you started measuring from here. I mean you always considered this as your baseline. So this was always one arm of the angle and you always calculated it in the clockwise direction. So clockwise direction it is 90, clockwise direction it is 180, clockwise direction in this case it is 240 degrees, and again clockwise direction in this case it is 360 degree. So whenever you are measuring angle while rotation, make sure that you follow the same reference so that you do not end up doing wrong calculations.